Okay.
Okay, so this is the measurement instrumentation lab. In this lab, students will be doing experiments related to circuits, sensors, and data acquisitions. First of all, we have these computers and Alvis board. So students will be building their circuits on here and testing it over the a virtual instrument on the computer. Right now, this computer is not on. This Alvis board also have built-in digital I/Os and analog I/Os, so they can also practice their skill with those. We have a couple of stations that students can learn about sensors and data acquisitions. For example, this station, this station is mainly focused on rotational speed measurement and strain measurement and linear displacement measurement. So in here, this portion is a rotational speed measurement. We use a proximity switch to measure rotational speed. And this is a crank slider mechanism. On the crankshaft, we have a strain rosette attached. So student will be reading strain as the thing is running. And this tube here, this is a LVDT for linear displacement measurement. So it's basically measuring the displacement of the piston as it moves. And students basically will need to set up the whole thing and then control this DC motor using the computer. We have a DC motor controller here. They control the DC motor using this controller, and then they take data from the data acquisition. This is a NI feedback data acquisition. We have two modules. One module for strain input, this module for strain input, and that module is for voltage input, because the output of the proximity switch and the output of the LVDT are both voltage. And so that one, and another lab here, this is another station that we have for a measurement lab. This lab is focused on a load cell and torque transducer measurement. In here, the main goal of the lab is basically to use this deadweight tester to calibrate a load cell and calibrate a torque transducer. So for this station, this is a load cell calibration station, and the other station here is a torque transducer measurement calibration station. What they will need to do is they apply different load using this deadweight tester on the load cell, for example, and then they take a reading. We have a data acquisition system here because both of the transducer, they are bridge-based. So we're basically taking a strain reading. We use a strain gauge module here. We take a strain reading and then calibrate that according to the load applied. Same thing, we use the same idea for the torque transducer. And then we also have these stations. These stations are built with many different functions. For example, here, for this portion of the trainer, it's a rotational position measurement. So here, if you look from this side, for example, this is an encoder that will be able to measure the position of the shaft as the shaft rotates. This is the encoder. Of course, it also has Hall effect sensors and optical sensors, things like those, for measuring rotational speed. And it also on this trainer, students can play with instruments such as power amplifier, differential amplifier. They are all built as module in here. all they need to do is to plug in their wire into the correct input and output and then hook it up into their circuit. So that's about it for measurement instrumentation. Thank you.